Hello everyone, I'm Dr. Buddhika Lienige. So let's talk about part 2 of nuclear chemistry, how to balance nuclear equations. Balancing nuclear equations that involve both atomic number balance and the mass number balance. Atomic number is equal to number of protons. You can see in the periodic table atomic number of each element. A mass number is proton count plus neutrons together. We called mass number. So we need to balance mass number and the atomic number from the reactant side to the product side. Nuclear equations like chemical equations, we'll write the reactant nucleus in the left hand side. Our reactor nucleus is parent nucleus, and then reaction arrow, the products. Products are the new stable nucleus plus the emitted particles. So you can remember first presentation we discussed number of there are three types of particles and one type of radiation emitted from the unstable nuclei: alpha particles, beta particles, positrons, and gamma radiation. So mass number is symbol A, that is total number of protons plus neutrons. So we need to match the left side, the sum of the protons plus neutrons count should be equal to the neutron plus proton count into the right side. Next, the atomic number or Z number, that is total number of protons. So Z numbers, all the Z numbers, if you add together in the left hand side, the reactant side, that should be equal to the all the Z numbers in the product side. Let's take example for the alpha decay. So emission of alpha particle. Alpha particle is helium nuclei. This is the symbol helium and mass number 4, atomic number 2. So unbalanced equation is given for you. Uranium-238 is our parent nucleus or reactant nucleus and product nucleus is thorium-234. Now, what is the particle? If you don't know this is alpha emission or beta or positron emission, how we can find the missing product? Step number 1 is first identify the emitted particle, either alpha or beta or the positron. So how we can identify? Just by looking at the mass number and the atomic number. So mass number 238 in the reactant side, the product side 234 plus, there should be something that is matched with 238. So you can clearly see 234 plus another 4 is equal to 238. Then the only particle we have for mass number is helium nuclei or alpha particle. Now this is the balance equation. So after we write alpha particles, if you match the mass numbers and the atomic numbers in both sides, 238 left side, 234 plus 4, 238 again the product side. Atomic numbers, 92 atomic number is left side and the right side total atomic number is 90 plus 2. 92. So both atomic numbers and mass number balance in the reactant and the product side. So this is balanced nuclear equation. Next, example for the positron decay. So emission of a beta plus particle, or we call positron. So beta plus particles or antiparticle of the beta particles, the symbol is 0 mass and plus 1 charge. Unbalanced equation is given. The same steps we need to follow. Identify what type of particle is emitted and then write the equation and then check the mass number and the atomic number in both sides. If we check the mass numbers, the upper left number 11 in the reactant side, product side 11 plus there should be 0 then. Uh, and the atomic numbers 6 and then 5 for boron and there should be another 1. 5 plus 1 is equal to 6 atomic number. So this is the balanced nuclear equation for the positron emission. So general tips when you are balancing nuclear equations. If you have alpha decay in a particular nuclear equations, always subtract 4 from the mass number and 2 from the atomic numbers from the original nucleus. Beta minus decay. The atomic number of daughter nucleus increases by 1, mass number remain the same. The reason is the beta and the positron both mass is 0. The beta plus decay, or we call positron decay, the atomic number of the daughter nucleus decreased by 1, Mass number remains the same because the positron mass is 0. Gamma decay, gamma is not a particle, it's a radiation. Only energy is emitted. No change in mass number or the atomic number. Therefore, always the gamma decay is accompanied with alpha, beta or the positron emission. I hope now you have idea about how to balance a nuclear equations, balancing atomic number and the mass number in both reactant side and the product side. Next presentation, we can see nuclear reactions part 3, half-life calculations. Thank you all for watching. If this is helpful, please subscribe the channel and comment any specific area if you need to discuss in the future.